Join me for this recipe review of the Colby cheese. American washed curd comes from Colby, Wisconsin, and was originally designed to replace the more complex cheddar cheese, which requires the cheddaring process, where the cheddaring process is replaced by a cold water wash. Let's jump right into it. Here, right away, you'll see what you're going to need. You're going to need milk, of course. For this recipe, I'm going to be using 1 gallon whole milk. You can make it raw or pasteurized. You're going to want a mesophilic culture. You can use store-bought MA4001 is an example. Floridanica is. You can use Clabber or cultured buttermilk. I'm also going to use single strength rennet and calcium chloride. I use calcium chloride only when I pasteurize my milk. Now, you can optionally use annatto, which is a coloring. It's a dye that will make your cheese look very orange if that is something you want to do. I always characterize my milk before I invest time to turn it into a cheese. And what does that mean, characterizing the milk? I'm going to go through 3 steps. First, I determine the fat concentration. I calculate the fat concentration. It's an approximation. You can see the equation here on the recipe. Essentially, I take a small amount of the milk, I pour it into a container. I have a graduated cylinder. It doesn't really matter what container you have. And then I determine ultimately the percentage of cream relative to the milk. So, for instance, if you pour it into a narrow glass, you could always measure the weight of the milk versus the weight of the cream at the cream line. Doesn't really matter what you use, how you measure it, but I like to estimate the percent of fat. And oh, by the way, I do see a difference since I buy my milk from either the dairy farmer or from the farmer's market. There is some seasonal variation. Now, has that carried into seasonal variation? So if I make a cheese, say a Colby in the summer versus one in the winter, can't say the cheeses don't last that long. I wish I could, but nope. So anyway, but I like to know the percent of fat that will affect the creaminess of my cheese. The second thing I always do is measure the pH of my milk. pH coming fresh milk is going to be somewhere between 6.6 to 6.75, even 6.8. The other reason for measuring the pH at the start is as you go through making the cheese, you'll see how well your starter or your culture is working. If you put it in and there's no change after a couple hours, your starter or your culture may not be working as well as you think it is. In any case, then I move on to number 3. I smell the milk. Really smell it. Not while I'm texting, not while I'm watching TV or YouTube or something. Stop and smell not the roses, but the milk. Then I taste it and I look at the milk. If you look at the milk, you should see it's kind of a suspension. Things are suspended in it. If you see globs, that means maybe something is in it that you don't want to be in it. Maybe your casein or maybe something has already started to ripen. But smell, taste, and look. That's at least the minimum to do. And if you're curious, determine the percent fat and the pH of your milk. All right, let's jump right into making the cheese. First, I use what's called a sous vide water bath. In my sink, I've washed my sink. I put in this device that will warm the water to a very exacting temperature, and I put my milk in that. That's called a sous vide water bath. I used to do it on the stove top, both electric and gas, and found in every case the bottom of the pot is going to be much hotter than the rest of the milk, right? Anything that comes in contact with the bottom of the pot will denature those proteins down there. So that was one thing. I also found using stovetop to be really difficult to control the temperature of my milk. So ultimately, once I discovered the power of the sous vide, how stable the temperature was, almost never go back. I do use the stovetop for when I'm going to do pasteurization. So I set my sous vide to the right temperature. When my water bath is at the right temperature, it's going to raise my milk to that temperature. I'll sprinkle the culture. In my case, I've made Colby a few times. I have used both MA4001 and Floridanica. I like the outcome from MA4001 better, but that's really just a personal thing. You can use either or any other mesophilic culture if you have a hankering to explore. And remember, you can also use your other cultures that you have made, like Clabber. So You add your culture and you allow the milk with the culture. You've stirred it in. You've let it sit for 45 minutes. At this stage, I'll measure the pH. If the pH has gone down from 0.05 to zero point 0.1 units, okay, my culture's working really well, and I'll go to the next step. If it hasn't, I'll do the ripening step for a full 60 minutes and again measure to see if the pH has dropped by zero point 0.05 or zero point 0.1 pH units, and then I'll move on. Next, we're going to set the curd. The traditional way that you set the curd, the recipe will tell you how much rennet to use, like a quarter of a teaspoon in 1 gallon. You'll dilute that quarter of a teaspoon in non-chlorinated water, about quarter of a cup, doesn't really matter how much. And then you stir it in to your milk, and you stir it in for, I don't know, 30 to 45 seconds. And then you make sure the milk is very still. You cover the pot and you leave it undisturbed for 45 minutes. You then insert a knife and you twist it. And if the break in the gel is clean, you're ready to move on to the next step. If the break is not clean or it seems very fragile, you let the gelation time continue for an additional 15 minutes. Now, personally, I use the flocculation method. I'm going to link the video that shows exactly how to do it, but I can tell you this is super simple and it has standardized how much rennet I use across all of the cheeses I make. And at this point, maybe 200 or more cheeses. In this case, I add the rennet, say a quarter of a teaspoon into the milk, into the water. I mix it in, and then to the surface of the milk, I put a little lid and I spin it. And that's time zero. And I keep spinning it about every minute or two until finally it stops spinning. That moment when it stops spinning is called your flocculation time. Let's say it stops spinning at 10 minutes. You now multiply your flocculation time by 3, and that would be 30 minutes, or 3.5, and that would be 35 minutes. But in any case, now you have the exact time that the gel process started, and you have a really good time of a calculated time of when you should stop it. All right, after it has finished setting up and I've tested for a clean break, the next step is cut, heel, and stir. So now I will cut the curd into half-inch cubes, working vertically and horizontally from all sides. You will see almost immediately whey starting to be released. That's called syneresis. And this is an important process in allowing the whey to start to escape from the inside of the curd. Now, what's really important here is that you cut the curd. You don't want to shatter them. You don't want to rip them. You don't want to tear them. You want it to be methodical and with something sharp. Don't use, something that is not sharp, so that the curds are not torn. After you cut the curd, you allow them to sit undisturbed for 5 to 10 minutes to heal. Then you'll stir them gently for 10 minutes. You'll also start to see the pH to drop a little more by about 0.1 or so. This is the this is the indicator of the activity of your starter plus milk microbiome. Now, if you've made more than a couple of batches of cheese, no doubt you've already seen that when you cut your curd, sometimes there's a lot of whey that comes out, and sometimes there's very little. I will tell you for this Colby batch, there was very little. And I think it was genuinely because I had new rennet and it's set up very fast. And so the gel had a different composition. I'll be really interested in telling you how the taste came out later on. All right, so after you cut the curd, you've let it rest. Now you're going to cook the curd. You raise the temperature to 102 over about 30 to 40 minutes. That's about 2 degrees every 5 minutes. And you stir gently this whole time. You really just want to make sure that the temperature in the pot is even. You're not mixing anything in. You're just stirring it and keeping your curds and your whey gently in motion. We don't want to harden the outside of the curd because if we do that, the whey will get trapped inside, and that will mean it'll be difficult to release. And your final step, you will have a softer cheese than is the target for the Colby. Anyway, as the curds move from wet, glossy, jelly like, and fragile, they'll become drier, They'll become more uh, the inverse of glossy, well, matte-like. They'll look more matte, they'll be less jelly-like, and they'll be firmer. So you will see that your curds actually change. Keep an eyeball out for this. The interior of your curds are still moist. So if the curd remains very wet, you'll want to continue stirring for 5 or 10 minutes, and then you'll allow them to settle. Now here comes the fun part that separates the I was going to say the cheddar from the Colby, but I think we've already done that by the previous step. But anyway, this will be our first cold water wash. The first wash, what you do, you've got your curd, it has settled, right? You're going to uh, either with a ladle or a cup or however you like, take the whey down to the top of the curd. Remember, now it's at 102 degrees. You want to remove the whey because the whey is the reservoir of lactose, the sugar. The bacteria love that. That's dinner for them. So by taking away the whey, you will reduce and slow the acid production. But we also want to keep the temperature so that the culture can continue to grow. So we're going to add cool water, and that will also start to increase the moisture of the curd. So take the whey down to the level of the curd, add water at 75 degrees. Remember, your curd is at 102. So you want to add cool water at 75. And you do this until the whole mass, the curd mass, falls to about 80, 85 degrees while stirring. When you reach that point, stop, let your curds settle, and rest for 5 minutes. Now we're going to do our second wash. Essentially, we're repeating the same thing. You're going to remove the whey from the top of the curd all the way down to the curd and add cold water at 60 degrees Fahrenheit until now the 75 degree or the 85 degree mass reaches 75 degrees. You want to add it steadily and keep stirring for 15 to 30 minutes. The curd will begin to become firm. It'll have a kind of skin that'll keep it from sticking together in the press, and it may even leave some small holes. Very unlike cheddar, right? If you've made that, you know it really wants to stick together. All right, we're almost at the finishing line. You're now going to put a cheesecloth on your colander, and you're gently going to decant your washed curds into the colander and to allow it to drain. This is where we're going to get rid of the largest volume, single volume of whey. Once that most of the whey is gone or all of it is gone, the easy stuff, you're now going to add the curd to a cheesecloth lined mold. For a 1 to 2 gallon cheese, the diameter of your mold should be around 4.5 to 5 inches. So we use a hard cheese mold. Specifically, the traditional setup is that it will have perforated bottom. It doesn't have holes on the side. And some, in fact, you'll see where the molds don't even have a bottom. But typically, it's a round, hard mold with solid sides and bottom drainage. You can see here the press schedule. There's really 4 steps for a total press time of 10 to 14 hours. We're going to start with the lowest press, 10 pounds. You're going to flip and redress it, 20, 40, and 50. You can see what's going on and the length of time for each here. Now, finally, nobody, at least in my mind, in the beginning explained, what does each one of these do? Why don't I just go right to 50 pounds from the beginning? Well, let's talk about that very briefly. In stage 1 and 2, shown up above with 10 and 20 pounds, this seals the surface and it helps the free whey to be squeezed out, essentially. If you press it too heavily, you can actually block the ability whey could get trapped in your cheese, and we don't want that. So the stage 1 and 2 is to press out some more whey and to allow it to escape. In stage 3, that's the knit stage, where the whey starts to knit together, the curds fuse into a continuous cheese. And then finally, stage 4 and 5, which is really shown here by stage 4, it's rind and shape. Little more whey will come out at this point. You won't see more whey in the morning once you're at 50 pounds. You're pretty much closing the surface and setting the form. After that final step, the 8 to 12 hours, you'll put it into a brine that has been saturated with dechlorinated water and either cheese salt or canning salt. You want salt that doesn't have a lot of other stuff added to it. And some people add calcium chloride too. This is optional. Now, I keep my 1 gallon of saturated brine in the cheese cave, which is between 50 and 55 degrees. So once my cheese comes out of the press, it goes right into the brine at that temperature. I also leave the exposed surface area. I also then sprinkle salt on that area. All right. Thanks for listening. I hope this is helpful. If you're interested in getting this exact recipe, just click the link in the discussion and you'll be able to download the recipe. Follow the next video because I've already tasted this wonderful cheese and you'll see the tasting results in the next video. Bye.